Kia ora, Year 9. This is the first extension video that I'm making this year, and this one is all about surds. And it's looking at what are surds and how we can combine them. So I've decided that this year I'm going to try something new. I'm going to use my dog to give an indication of how hard the video is. So this video level, I've decided, is worth 4 bonnies. Now 4 bonnies means this is far more than you need for Year 9 maths. But these things are really fun and I hope you enjoy them. But you won't have to do anything beyond the very, very easiest examples in here in any kind of Year 9 testy thing. So this video is just to let us have a look at how we can think about some really, really cool numbers. If you're watching this from Wellington College, when you get to the end of this, there's a worksheet that goes with this that picks up from the last kind of the concept in the last slide. Make sure you've got your maths book out, guys, and a pen so that you can work along with me. If I'm going too slowly, put me on double speed. I don't mind if it sounds really stupid. So let's start by having a look at what is a surd. And we kind of might know that there's something to do with the square root sign or the root sign. But I want to try and build us up to a slightly better definition than just, oh, there's something to do with the square root sign. Because some of these things here are not really surds, right? So if we see this first one, this is the square root of 9. Well, this is simply equal to 3, right? Because 3 3s will get me back to 9. The next one, the square root of 4, is equal to 2. The square root of 36 is 6. Now this one here extends the notation a little bit. So when you see this little number 3, that means that I've got the cube root of 27. So I want what times what times what will get me to the number under the root sign, or sometimes called the radical sign. And the answer to that here is 3, right? So 3 times 3 times 3 will get me 27. The cube root of 8 is 2. And then we've got a few more, right? So we've got the fourth root of 16. So what times what times what? How many whats? What will get me to 16? Well, 2 times 2 times 2 times 2. So there you go. So far, all of these surds that we've had have simplified because the numbers inside are all square numbers. And that's really the kind of the guts of what this video is about, is that when we're working with surds, we are, sorry, they're not all square numbers. These ones are all square numbers. These are cube numbers, right? We're looking for the kind of matching power. So if I'm working with a square root sign, I'm hunting for squares underneath my square root sign. And when I find one, I can simplify, right? And so that means that the square root of 9 is 3, and 3 is an integer. So when we first learn maths, we start with learning what we call the natural numbers, right? So just a little bit of kind of really basic thinking about my number line. When we start out, the first number we learn is 1, and so we have 1, 2, 3, and we call those the natural numbers. Then we extend it and we put in 0, which is a big deal at the time, right? And we call those the whole numbers. I think we call them the whole numbers. If we think about a diagram like this, we've got the natural numbers are the counting numbers 1, 2, and 3, right? And then we extend it and we put in 0. And after that, we put in the negative numbers, and we call those integers, right? So you can kind of see that the square root of 2 is more complicated than an integer. Oh, where has my picture gone, right? So it's more complicated than an integer, but there's a group of numbers that are in between how kind of weird these ones are, and they are called the rational numbers, right? So the rational numbers are any numbers where we can write them as a fraction with an integer in the numerator and an integer in the denominator, right? For example, 501 divided by 617 is a rational number. But there are numbers that we can't write as rational numbers. And I'm not going to prove today why we can't write the square root of 2 as a rational number, because this video has a time limit of only 15 minutes because I use the free version of Screencast-O-Matic. But out here, we've got what we call the real numbers. And the real numbers are made up of both the rational numbers and the irrational numbers. And surds sit out here because they're irrational numbers, right? So remember, so far, we haven't been working with any surds because all of these are simply integers, right? But the next couple we've got here are surds. We can't simplify the square root of 11 any further, right? There's no something times something equals 11 where it's the same something, right? The same thing with 47. So that's as far as we can simplify those. So these two things here are finally surds. Now, what about the square root of 50? Well, this is one where we can simplify it, but not all the way down to it being an integer. So we're going to come back to that in a minute. So just a couple of notes for your book that I'd like you to take down, please. So write these out neatly. What's a rational number? Well, a rational number is one that can be written as one integer divided by another integer. And then a surd is the square root or the root of a rational number that is not itself a rational number. Okay, so for example, the square root of 11, well, this number is a rational number because it's an integer, right? So integers are part of the group of rational numbers, right? But it's not a rational number itself. So that's a surd. Okay, right, let's have a look at a few for you to try, and we're going to move up to doing some work with fractions. So take a look at these, pause the video here, and just try and simplify where you can, and then decide which ones are integers, which ones are rational numbers, and which ones really are surds. So this one's 5, that can be simplified. That one we can't, that one we can't. Now what about this fraction one? Well, we want something times something is equal to 1/9. And the two fractions have got to be the same. So let's try 1/3. So 1/3 times 1/3 will get me back to 1/9. So that's the square root of 1/9. What about the square root of 4/9? Well, let's try something similar. We want to end up with 9 in the denominator. So we could put three threes here, and we want 4 in the numerator, so 2 2s. So the square root of 4/9 is 2/3. This one here, the first thing we should do is to simplify that fraction down to the square root of 1/7. And we can't go any further with this. So this one here is an integer. This is a surd. This is a surd. These two are rational numbers, but not integers. And this one is a surd as well. Okay, next we're going to look at how we can simplify surds. And we're going to start by looking at what we can notice when we think about the square root of 36. So if you think about the square root of 36, what times what gets me 36? It's 6, right? Which is the same as 2 times 3. So I could rewrite that surd, instead of 36, I could write 4 times 9, right? And you'll notice that that matches up to the 2 3s. So in general, if we have this, we can rewrite it like that. And if we have the square root of a divided by b, we can rewrite it like this. And again, if you could put those notes into your book, that would be great. Okay, so now we're going to try simplifying these surds and seeing what we get. So the square root of 24, well, there are lots of factor pairs of 24. So let's see how far we can take this. Let's do, first of all, 2 times 12. Now my rule up here tells me that that is equal to the square root of 2 times the square root of 12. Can we simplify? So the square root of 2 is as far as we can go. But can we simplify the square root of 12 anymore? Well, yes, we can, because we've got the square root of 2 times the square root of, let's go with 4 3s. So now we've got the square root of 2 times the square root of 4 times the square root of 3, right? So I'm just using this rule. And that gives me the square root of 2 times the square root of 2 times the square root of 3. But now we can put those two back together and we get 2 root 3. And this is what we call a simplified surd, right? Because here, the number inside the surd sign is as low as we can get it. And we've got 2 lots of root 3. So you'll notice here that I didn't write 2 times root 3. I drop out that times sign. And if you're watching this, you may well have done some basic algebra, and you'll know that we don't need a multiplication sign when we're doing multiplication with algebra, and we don't with surds either. Okay, so that was a really, really long way to go with that question on Route 24. I'm wondering if you can spot a faster way to get from here down to here. So we didn't have to pick 2 times 12. Now I'm going to pick something else stupid and see if that works, right? So the square root of 24 is equal to the square root of 3 times 8, and that equals the square root of 3 times the square root of 8. But we can do a factor pair on 8 of 3 times 4 times 2, which is the square root of 3 times the square root of 4 times the square root of 2, and again we get this. What have I done? I've done something weird here. What have I done? 3 8s, 4 2s, 2 root 2. So that gives me 2 root 6. I've done something wrong over here. Oh, guys, you've just seen me make my first big mistake. So what did I do? Yeah, here's my first big mistake, right? First big mistake of 2023. And look, I'm going to leave it in here, partly because I already made this video twice and then had to go and get dinner. So there's my big mistake. So for those of you who were sitting there screaming at the screen that I had mucked it up, yes, you were right, and I was wrong. So that's wrong. So let's get rid of this. I'm leaving that mistake in on purpose, right? I think one of the things that you need to learn as you're going through maths at high school is that it's fine to make mistakes as long as we're checking our work and we try to find them before we go too far, right? So I'm deliberately leaving that in. That is my story and I'm sticking to it. So now, rewriting this one, I've got 2. I'm going to put the big number first. So I've got 2 times the square root of 2 times the square root of 3. And I'm going to put those back together. And I get 2 root 6, right? So what we're trying to do is to pull out as big a number here as we can and to get this as small as we can. I'm going to do the next couple, but I'd like you to have a go at them first. And I want you to see if you can find a better way to do what I did so that we get down to this line here or this line here without all of this working, right? And I think you'll figure it out pretty fast. Okay, so let's do the square root of 32. Now, if I pick a square number for my factor, watch how easy it is. I've got the square root of 16 times 2, which is this. Square root of 16 is 4, so I get 4 root 2. So by pulling through the factors that are squares, I can do these really, really efficiently. Okay, so that's the square root of 32. Next up, we've got the square root of 200. So the square root of 200 is equal to the square root of 2 times 100. And that's the same as the square root of this times the square root of this. Square root of 100 is 10. So I get 10 root 2 in there. And you can see how fast that is compared to doing all of that, right? Lastly, the square root of 75 is equal to the square root of 3 times 25. This isn't a square, but this is a square. The square root of 25 is 5, so I get 5 root 3. Okay, last page. In 1 minute, I'm going to look at how we can combine surds. So once we've simplified, we can add them together as if they're apples or bananas. So this first one here is going to be equal to, so we've got 3 times 25 plus root 3, right? So that's equal to 5 lots of root 3 plus root 3. That's equal to 6 lots of root 3. So that's how we can simplify from there to there. And that's what the extension worksheet that goes with this video for Dub C students is all about. I'm just going to do one more. I'm going to do this one here, and then I'll leave those for you to do on your own. Okay, square root of 18 is the square root of 2 9s plus 2 root 2. So what have I got here? This one simplifies to 3 root 2 plus 2 root 2, which gives me 5 root 2, and so on. So you can have a look at these. Some of these will simplify, and some of them won't simplify. They're only going to simplify where I've got apples and apples, or bananas and bananas. Thanks for watching. I'm sure you'll leave me comments in the comment space if there's any mistakes. And if you're watching this from school, now's the time to go and have a go at the harder worksheet.